Okay, for this set of problems, we are working with velocity, acceleration, and position. And for this particular problem, we're trying to find the position function x of t of a moving particle with the given acceleration a of t, initial position x naught, and the initial velocity v naught. Okay, so we have a of t is equal to a constant at minus 20. V naught is also a constant where the value is at negative 15. And x naught is also a constant where we have set equal to 5. Okay, so if we're looking for x of t, okay, first of all, okay, for corresponding the acceleration with velocity. And again, by definition, okay, we have the change in velocity with respect to the change in time is equal to acceleration. And for what we have here, the acceleration is negative 20. So you have dv over dt is equal to negative 20. And looking at separating the variables, or in this case, separating the differentials, we have that dv is equal to negative 20 dt. And upon separating, we can integrate on both sides. So the antiderivative of dv is v, and for the integral of negative 20 dt, okay, we have negative 20t plus c sub 1. Now we have v naught is equal to negative 15, so applying substitution, okay, so you have the v of 0 is equal to negative 15. Applying substitution, so v is at negative 15 and t is at 0, and automatically the first constant is equal to negative 15. So putting the velocity in parametric terms and having determined the value of the constant, we had that v is equal to negative 20t minus 15. And looking for the position function, now we have by definition, okay, the change in the position or change in distance with respect to the change in time is going to be the velocity. And we have established, okay, the velocity is equal to negative 20t minus 15. And separating the variables, or in this case the differentials, we have dx is equal to all of negative 20t minus 15 dt. After separating, okay, we can integrate. Left-hand side becomes x, and with the power property of integration, we have negative 20t with an antiderivative of negative 10t squared. For negative 15, this will go to negative 15t, followed by the second constant, and specifying what the second constant will be. And again, we have the initial distance or position is going to be at x of 0 is equal to 5. And substituting accordingly. So x is at 5. And the parametric terms, okay, those are going to be negligible. And so automatically we're going to have that the second constant is equal to 5. And once again, we're going to have for x at any time t with the given conditions, okay, we're going to have this equal to negative 10t squared minus 15t plus 5. and that will be the resulting x of t. Okay, for this problem, we have a of t is equal to 2t plus 1, and we have v naught is equal to negative 7, and x naught is equal to 4. Again, so we have dv over dt is equal to a, which is equal to 2t plus 1, and separating the differentials. So we have dv is equal to the quantity of 2t plus 1 dt upon integrating on both sides. Okay, we have that v is going to be equal to t squared plus t plus a constant, and we'll refer to this as c sub 1. And again, we have with the initial velocity, we have v naught is equal to negative 7. So v is at negative 7. And guess what? If I set t to 0, and guess what? 0 squared is 0, plus 0 is 0, and we have plus c sub 1. And guess what? C sub 1 is equal to negative 7. So we're going to have for the velocity, that is equal to t squared plus t minus 7. And looking at finding out, okay, what the function x of t is going to be. So again, we have the change in distance with respect to the change in time is going to be the velocity. And again, the velocity we have determined to be t squared plus t minus 7. Once again, separating the differentials. And dx is going to be equal to the quantity of t squared plus t minus 7 dt, integrating on both sides. So you're going to have the x is going to be equal to 1/3 of t cubed, or you could also write that as t cubed over 3. And we have plus 1/2 of t squared minus 7t plus another constant c sub 2. And we have, in solving for the second constant, we have that x naught is equal to 4. So x is going to be at 4. And guess what? For the parametric terms, upon setting t to 0, we have the items right before the constant to be rendered negligible. So you're going to have that c sub 2 is equal to 4. And so we have, for the full solution of the position function, we're going to come out to x of t is equal to 1/3 of t cubed plus 1/2 of t squared minus 7t plus 4. And that is the result. Okay, for number 15, we have the acceleration given in quadratic terms. We have 4 times the square of t plus 3, and we have v naught is equal to negative 1, and x naught is equal to 1. And what I'm going to do here, I'm just going to go ahead and expand what I have for a. Now for the square of t plus 3, that will be t plus 3 times itself. So we have 4 times t squared plus 6t plus 9. And that's going to be 4t squared plus 24t plus 36. Now again, we are solving for the position function x of t. So just creating the pathway. Okay, so the change in velocity with respect to the change in time, again we have equal to the acceleration, which again we have at 4t squared plus 24t plus 36, and separating the differentials. So you have that dv is equal to all of 4t squared plus 24t plus 36 quantity dt, and integrating over both sides. So you have the v is equal to 4/3 of t cubed plus 12t squared plus 36t plus the constant c sub 1. And for the initial conditions, okay, so we got v naught is equal to -1, and filling in, so v is at -1, and with t at 0, okay, you have the terms in t cubed, t squared, and t to be negligible once again, so we have that c sub 1 is equal to -1, and so we're going to have that the velocity becomes 4/3 of t cubed plus 12t squared plus 36t minus 1. And for the position function, again we have dx over dt is equal to v. Again we have 4/3 of t cubed plus 12t squared plus 36t minus 1, and separating the differentials. So you have 4/3 of t cubed plus 12t squared plus 36t minus 1 quantity dt, integrating on both sides. So we have x is equal to, okay, so you're going to have what will be 1/3 of t to the 4th plus 4t cubed plus 18t squared minus t, plus the second constant. So we have x naught is equal to 1, and with t at 0, it's going to turn out automatically that c sub 2 is equal to 1. So we have for any time t, we're going to have that x is equal to 1/3 of t to the 4th plus 4t cubed plus 18t squared minus t plus 1.